NASA gave a fundamental knowledge. Pluto isn't what you think. What is NASA proposing here? Are they inferring the latest divulgences from the New Horizons space probe, which shows that odd things are occurring on Pluto's surface? One of the dangerous pictures for sure shows something that appears to drift across the outer layer of Pluto. This raises disturbing questions about whether some kind of high-level dark life exists on this faraway world, or are we dealing with an effectively recognized geological brand name? Pluto may be barely anything, but the accounts it holds to tell are huge and, furthermore, stacked with surprises. At the point when Pluto's planetary status was revoked in 2006, analysts were ignorant of the data from the New Horizons probe, which had just arrived at Pluto after years. Since then, we have understood that there is more to this smaller object than was expected. How did cosmologists truly come to deny this planet, which we have all, in some way, grown up with? Everything was going on with a real planet. It had been that way after the discovery of several other small planets in the Kuiper Belt. They considered that we really needed a limit for what is a planet and what is a dwarf planet or trans-Neptunian object. How did astronomers deny Pluto? It scored points for its size and round shape, but the planet shares its orbit with several other things. The orbit is therefore not considered to be perfect, and this was the defense for why Pluto was not commonly associated with the other massive planets in the planetary system. Many people on Earth think this is a shame, and this decision by space specialists caused disappointment among people overall. Pluto, now not a planet, was a dangerous thought for some. The fact that this small, crazy planet has so many fans on Earth prompted letters of protest to NASA from prominent scientists who supported the minimization. Honestly, even state-run organizations got letters from residents requesting Pluto to be a planet again. This planetary status had been with us since the 1930s and was a critical part of a group of 9 planets. It was like a cutting-edge idea. In 2015, when New Horizons sent us the first real picture, the Pluto-Earth mover, the planet showed us its charming face. Imagine it. It was the first real image of Pluto. If you've seen the planet on sheets or in school materials before, they were creative depictions, not real pictures. Pluto defied even the truly verified pictures of Pluto from the Hubble telescope, offering a clearer perspective on its surface. In a manner, New Horizons was allowed to photograph the little one as it really is. Amazing, very well arranged, and, of course, rich with a heart. From that point forward, the planet on the outer edge of the planetary system has gained significantly more fans, and perhaps space experts will change their viewpoints one day, and we will get Pluto back. The main guaranteed pictures of Pluto blew everyone's mind. It was a treasured moment when the first data from the New Horizons probe arrived at mission control in 2015. Everybody present knew that they were going to see a planet for the first time, one that everyone was somehow familiar with yet had never seen up close. The computers on Earth gathered this captivating picture from immense amounts of individual pieces and pixels. What the probe revealed about Pluto was a discovery that completely turned our understanding of this distant planet on its head. Pluto is altogether more changed, generally more arranged, and essentially more alive than planetary researchers had previously perceived. In addition, the little planet appeared to be shrouded in pleasant features and maybe even significantly more regular eccentricities that nobody had expected. With each new piece that New Horizons allowed, the faint, stupefied world in the darkness of the Kuiper Belt turned into something significant that showed such an overflow of life that it blew specialists' minds. Increasingly stunning geological phenomena opened up before the experts. Instead of the normal freezing and cratered dead, zoned land, Pluto turned out to be an intriguing place with extraordinary pieces of ice, deep gullies, and smooth, cold surfaces. It demanded an extremely long time for the interminable assessment, data, photos, and revelations to make the long journey from Pluto to Earth. Since 2015, we have been flabbergasted essentially a time or two with new captivating viewpoints of Pluto. One of these perspectives is walking on Pluto's surface. It's astonishing. This moving picture streamed in the media in 2016. At any rate, what could you imagine seeing here? It appears to be like an individual is walking across an amazing honeycomb-shaped snow float. You can genuinely see ice honeycomb landforms here. However, unlike on Earth, these frozen surfaces are not made of water but of nitrogen and methane. Researchers recognized the shocking thing as a dirty piece of ice, which seems to be floating over the surface of the ice-covered plain. The large block of ice is, in fact, made of incredibly solid nitrogen. These particularly looking landforms revealed something very wonderful to the researchers. They now believe that there is a nitrogen supply several kilometers beneath Pluto's surface, where the solid blocks form geographical advancements within the planet, pushing these blocks upwards and making the honeycombs and fields like the apparently wandering mountains. This points to a warm center of the planet, and this discovery is a hint that could have wide implications for how we may interpret Pluto. It is certainly more interesting than previously perceived. Land development from heat, alongside changes in surface plans, shows a sort of aliveness that suggests we have misjudged Pluto. This smaller object shows some thought as well as fire in it, and that would without a doubt suggest that there are pockets of liquid inside Pluto that seem to be like oceans or magma. The geography team of the New Horizons mission, led by William McKinnon, even compared the internal presence of the small planet to an incredibly large scale like Hudson Bay in Canada. Virtual experiences showed that this striking scene developed over hundreds of years and is still amazingly unique today. Could you see the specific X on the right beneath the stew mass? This plan was probably made by sublimation, a process in which a substance changes directly from a solid to a gaseous state and the liquid stage evaporates. These cycles occur due to the extreme temperatures on Pluto, jumbling geological cycles, and natural eccentricities. In a dead world, Christmas in the snow on Pluto. Does that sound insane to you? Well, it's a reality. Pluto truly is a secret. The New Horizons mission revealed interesting pieces of the climate and occasional changes on this planet. Pluto, which orbits neglected distant regions of the Kuiper Belt, has a climate, a thin layer of nitrogen, methane, and carbon monoxide that changes drastically depending on how close or far Pluto is from the Sun. The changes affect the environment as well as the surface conditions of the dwarf planet. One particularly bright aspect of the natural variables is snow on Pluto. This snow contains primarily frozen nitrogen and methane. Unlike Earth, where snow forms only from water, the extremely low temperatures on Pluto cause the more unstable gases, nitrogen and methane, to accumulate and fall as remarkable snow. All of these associations shape and invigorate Pluto's surface by covering the landscape with new deposits. These disturbances drive other geological developments like cold movement and perhaps cryovolcanic cycles. The New Horizons research also showed that these seasonal cycles are closely tied to barometric pressure. When Pluto is nearest to the Sun, the little light is enough to heat up the dwarf planet's atmosphere, causing it to expand slightly and rise. When Pluto moves farther from the Sun again, the environment freezes and sinks back to the surface. This idiosyncrasy leads to a striking anomaly. When Pluto's environment gathers, it could literally snow with snow made of nitrogen and methane. The variations in surface brightness and the distribution of coal deposits further suggest that practically all surface features, and thus scenes on Pluto, are connected to these environmental cycles. Since Pluto's mountains are not made of rock but of ice, which is entirely versatile on this world, the whole surface moves significantly more than that of our Earth. For example, what does Pluto's heart contain? Who might have guessed that Pluto's heart isn't simply a warm engraving? In spite of its distinctive appearance, this region is also perhaps one of the most astounding districts on Pluto. Previously considered Sputnik Planitia, the Sputnik Planitia region is named after the first artificial satellite, Sputnik 1, which the Soviet Union sent into space in 1957. This huge heart-shaped ice surface extends across an area of around 1,000 kilometers and consists mainly of nitrogen ice with traces of frozen methane and carbon monoxide. The bright, almost perfect surface of Sputnik Planitia forms a sharp contrast to the darker, more complicated areas around it. Geographically, Sputnik Planitia is a colossal impact structure that was most likely later modified by volcanic cycles. Not by the standard volcanic movement on Earth, where magma rises from the planet's interior. Volcanism on Pluto involves cold materials rising from the dwarf planet's interior to the surface. The heat sources inside Pluto cause nitrogen and other volatile substances to heat up and push upwards, where they freeze and form special arrangements like this one. Sputnik Planitia is strikingly level, which leads researchers to believe that the frozen surface is constantly being renewed by internal cycles. It's likely convection processes inside the ice sheet that form these scenes. Researchers anticipate that there may be a range of liquid water beneath the smooth ice sheet of Sputnik Planitia, which is kept liquid by the heat inside Pluto. Researchers wonder whether forms of life can exist in the subglacial ocean, but it's not entirely impossible. What role does Charon play? What barely anyone knew is that before the New Horizons mission, Pluto had its own moon, and not just one. Charon is Pluto's biggest moon and was discovered in 1978 by the American astronomer James Christie. Charon is extremely large in comparison with Pluto, with a diameter about half of Pluto. This has led to a significant association between Pluto and Charon, where the two objects are tidally locked, meaning that Pluto and Charon always show the same side to one another. Charon's surface is also incredibly unique compared to Pluto's, with huge cliffs and massive impact craters. Researchers believe that Pluto and Charon have been trading materials in the form of comet-like objects. Pluto, once considered the 10th planet in our solar system, has long captured the imagination of astronomers, scientists, and the general public alike. Discovered in 1930 by astronomer Clyde Tombaugh, it remained as an image of planetary investigation and mystery. Anyway, in 2006, the International Astronomical Union (IAU) renamed Pluto as a dwarf planet, starting discussions and debates. Nonetheless, this change didn't stop Pluto from continuing to interest scientists and enthusiasts who wanted to learn more about this far-off object on the edge of our solar system. NASA's new warnings about Pluto's true essence, encapsulated in the phrase "Pluto isn't your thought process," are now drawing renewed attention to the puzzling scene. This phrase, often combined with compelling statements about the dwarf planet's intricacy and importance, hints at discoveries that have emerged through the latest missions, observations, and research. While many aspects of Pluto's composition have been confirmed over the years, there remains a continually developing understanding of its secrets that confound our assumptions. Through NASA's investigation of Pluto, especially by the New Horizons mission, we are learning like never before. In this article, we will explore the latest discoveries, scientific advancements, and the growing impression of Pluto as a planetary body. From its dubious renaming as a dwarf planet to the current discoveries about its formation, atmosphere, and potential for future exploration, we will examine how NASA's research is continuing to reshape our understanding of this cold world at the far reaches of our solar system. Pluto's transformation from a planet to a dwarf planet in 2006 was met with mixed reactions, with some scientists agreeing with the International Astronomical Union's decision, while others disagreed, considering it a disservice to this iconic object in our solar system. However, the discoveries from NASA's New Horizons mission have reignited public and scientific interest in Pluto, revealing a world far more complex and dynamic than once thought. The mission, which reached Pluto in July 2015, provided the first detailed images and data of the dwarf planet, revealing unexpected features that have forced planetary scientists to reconsider much of what was previously understood about this icy world. One of the most astonishing aspects of Pluto is its surprisingly active surface. For decades, Pluto was thought to be a cold, inactive world, but the New Horizons data suggested otherwise. The discovery of diverse geological features such as ice mountains, smooth plains, and deep valleys on Pluto's surface revealed that the planet's surface was far more geologically active than previously believed. One of the most striking features discovered was the large, heart-shaped region known as Sputnik Planitia, a vast, frozen plain made primarily of nitrogen ice. The region's smooth, young surface suggested that it has been recently refreshed, possibly due to internal processes beneath the icy crust, which may involve cryovolcanism, a form of volcanic activity that involves the eruption of volatile substances such as water, ammonia, or methane, rather than molten rock. The New Horizons mission also uncovered evidence of possible liquid water beneath Pluto's frozen surface, which would suggest that the dwarf planet might harbor the conditions necessary for life, at least in some form. The possibility of a subsurface ocean is made more plausible by the presence of heat-producing processes within Pluto's interior, which could keep water liquid in pockets beneath its icy shell. This has sparked speculation about the potential for microbial life, as similar subsurface oceans on moons like Europa and Enceladus have been considered promising locations for life beyond Earth. While the idea of life on Pluto remains speculative, The presence of such internal activity on this distant world challenges earlier assumptions about its dead, frozen nature. Moreover, Pluto's weather systems also defy expectations. NASA's data has shown that Pluto experiences seasons and weather patterns, albeit much more extreme than what we experience on Earth. The dwarf planet's atmosphere, composed mainly of nitrogen, methane, and carbon monoxide, undergoes significant changes as Pluto moves along its elliptical orbit around the Sun. As Pluto approaches the Sun, its thin atmosphere expands, and when it moves farther away, the atmosphere contracts. This cycle affects surface conditions, causing nitrogen and methane to freeze out of the atmosphere, creating snowstorms of these gases. The planet's thin atmosphere also means that the snow that falls on Pluto isn't made of water, like on Earth, but rather of frozen nitrogen, methane, and carbon monoxide. Another intriguing discovery was Pluto's complex, tectonically active surface, a feature that sets it apart from other celestial bodies in the Kuiper Belt. The surface of Pluto is not static, as previously thought, but appears to be constantly reshaping itself. The presence of expansive ice fields, jagged ice mountains, and even possible signs of tectonic shifts on the surface suggests that Pluto's interior might still be geologically active. This discovery challenges the idea of Pluto as a frozen, lifeless body and raises the possibility of internal heating mechanisms, such as radioactive decay or tidal forces from its moon Charon, which could be driving this activity. Charon itself, Pluto's largest moon, has also provided fascinating insights into the Pluto-Charon system. The mutual gravitational interaction between Pluto and Charon, where both bodies are tidally locked, leads to unique geological and gravitational effects. For instance, Pluto and Charon share a common center of mass that lies outside Pluto itself, leading to a very distinct orbital dynamic. Charon's surface, with its deep canyons and extensive cratering, also provides clues about the history and evolution of both Pluto and its moon. Evidence suggests that Charon was once geologically active, and like Pluto, its surface has undergone significant changes due to internal processes. The latest discoveries from Pluto highlight that this distant dwarf planet is much more than just an icy rock at the edge of the solar system. Its complex atmosphere, dynamic surface, and possible subsurface ocean make it one of the most intriguing objects for future exploration. As NASA and other space agencies continue to study Pluto and its moons, it's clear that this small, icy world has many secrets still waiting to be uncovered, and the quest to understand Pluto is far from over. Future missions may reveal even more surprises, perhaps even providing insights into the potential for life in the most unexpected places of our solar system. Pluto, once considered a simple icy body, is now viewed as a dynamic and mysterious world that is reshaping our understanding of planetary science.